All right, last video for this first chapter, Unit 1A, 17 through 22. Looking at this problem here, I'm going to multiply everything by the common denominator. So I'm going to multiply the entire left side by my common denominator of 5x and the right side here by 5x. All right, so when I distribute through, the x's cancel. I'm going to get 5 plus. 5's cancel. I'm actually going to have to distribute the negative through to both parts. So realize the 5 here is canceling again when it comes through, but then I have to distribute the negative through. So that's going to be, the x through. That's going to be 2x squared plus 6x, and that's going to equal, these completely cancel, 1. Right? So what I want to do here is I want to get everything to one side and the other side equal to 0. So when I do that, I'm going to have 2x squared plus 6x, and positive 5 after I subtract the 1 turns into a positive 4, and that's going to equal 0. So immediately when I get a quadratic, I start thinking about factoring, and I actually can pull out a GCF here. That would be 2 times x squared plus 3x plus 2 equals 0. And then I'm going to try to factor the trinomial that's left, which I can. So I have 2 quantity x plus 2, x plus 1, that's the correct factorization, equals 0. And then when I do my splits here and try to find my two answers, the 2 isn't going to affect anything because that can't equal 0, but when I check these two binomials, I will get answers of x equals -2, and my other x answer would be -1. You always want to check your values back in, especially when we get to these radicals and absolute values, but right now, the only answer we can't have over there is 0 because we had a x in the denominator, which would make it undefined. These are both good, so we can move on. All right, looking here, we want to be careful. You want to add b to both sides before you draw any conclusions about a negative there. So we'd actually have, b minus 1 on the left side if I add b to both sides, and that equals, having a hard time seeing this, okay, that's a 7 minus 7b. So radical 7 minus 7b. Now I'm at the point where I would want to square both sides, and it works out really nice on the right side. We get 7 minus 7b, but on this side we really got to get confident with rewriting and foiling or expanding binomials squared. So that's going to be b squared minus 2b plus 1. And as we're getting confident in this, we get a quadratic, so we get one side equal to 0. So I'm going to add the 7b, which is going to give me b squared plus 5b, subtract the 7 from both sides, so I'll get minus 6 equals 0. And what we do again is we want to try to factor, get in the habit of that. We're going to see that a lot this year. So we get b plus something, and we get b minus something. So we're thinking b plus 6 and maybe b minus 1 equals 0 would be our factorization, which it does work out nicely. So our two possible answers here are -6 and +1. Well, we want to go back and we want to check. So when you actually check -6, you're going to get, this is hard to write up here, so I'm just going to talk through it. So when let me get a different color. When we're checking in red here, we're going to get -1 equals the opposite of -6. So that's just going to be a 6 right there. And in here, we're going to have 7 minus 7 times -6. So that's going to end up being 7 minus -42, or 7 plus 42, which is 49. Square root of 49 is 7. So 6 plus 7 is 13, not -1. So we have to reject that answer. I'm going to save the time right now, but if you check one, if you plug it in and check it, it does work out. It is a solution. All right, moving along. For these, we also want to get the absolute value alone first. So this is tricky. Don't subtract those first. You need to add 4 to both sides. So the first thing you need to do is get the 4 to the other side by adding 4 to both sides, which is going to give me a -28. Then I want to divide both sides by -7. I'm speaking out the work because by writing it, I take up a lot of space here, but dividing by -7 would give you a +4. Now we have two possible scenarios happening, so we do our split. X plus 2 could be 4, or x plus 2 could be -4. Okay. okay? And then when we solve each of those, we get an x value of 2, and we get an x value, subtract 2 from both sides, of -6. And when I plug both of those in, those both work. All right, and then looking here, it looks like on this one, the absolute value sign was lost. It's supposed to be right there. All right, so looking here, we want to add the 3 first. So what we have here is we've got 6 times the absolute value of -5 plus r, absolute value, equals, and we're going to add 3, so we'll be at -78. Okay, so here's the deal. Right now, I can tell you from experience, and hopefully you're getting there, that this is no solution. Because you're taking a +6 and you're multiplying by an absolute value, which will always be positive, and you're getting a negative answer. You're not going to be able to get that to happen in the real number system. So I know right away that that is no solution. Looking here, solve by factoring. A little more practice with this. You want to get one side equal to 0, 7x squared, add 38x to both sides, so we have here, and then we're going to add 15, set it equal to 0. So they're asking us to factor here, and after guessing and checking, playing around, we hopefully will get the right answer. But hopefully you're taking educated guesses here. I have both positive signs, so that's going to tell me from experience that those are both pluses. 7's a prime number, so we're going to have a 7x and a 1x. And then if I start playing around with values, I should be able to find out which one works by doing FOIL each time. And when I do that, I'm actually going to get a 3 and a 5. This does FOIL out and give me here. So now, the reason that this answer is -5 is because of the concept of the zero product property. When you have something times something and the answer is 0, each of those somethings, binomials in this case, have to, or could be 0. So that's why I solve each of these and I get -5 here, and when I actually take 7x plus 3 and set it equal to 0, I subtract 3 and divide by 7, I get -3/7. And again, you want to check your work. Both will end up working here. All right, solve each equation in the quadratic formula. So I have to first set it up for the quadratic formula. So x squared minus 12x looks good there. And then 18 has to get over to the other side. So I'm going to subtract 18 from both sides. Now I have here my a value here, b value here, and, oops, sorry, not going there. A value here, b value here, and c value there, keeping the negatives with those coefficients. So I'm going to do the quadratic formula, which is x equals the opposite of b, so that's 12, plus or minus the square root of b squared, so that's going to be -12 squared, which is 144, minus 4 times a, which is 1, times c, which is -18, and this is all over 2 times 1, which would be 2. So we're going to have to show, I don't have a lot of work here, if I can go down a little bit. All right, here we go. So we're going to have to show, without a calculator here, we're going to be able to do the quadratic formula, so 12 plus or minus the square root of 144, and in here, this is called the discriminant, which is where a lot of kids make mistakes. Just be very careful. You have a negative, positive, negative. So I know when I multiply those, there's going to be a plus sign here. And now I just got to find out what 4 times 18 is. And 4 times 18 is 72. This is still all over 2. All right, so moving along, making progress here. X is equal to 12 plus or minus the square root of 216 all over 2. And now I want to simplify that 216 radical there. So after you do that, and again, you practice simplifying your radical and get comfy with that, you should be able to break that down into root 36 times 6, or 6 root 6, and we're still over 2. And now it's at this point that you can start thinking about simplifying, and you definitely want to look at all 3. We got to get a number that can come out of all 3, not just the first 2, not just these 2, but all 3 to go any further. And we have absolutely the number 2 that comes out. So we could say our final answer to this problem is, take a 2 out, we have a 6, plus or minus, take a 2 out, we have a 3, root 6. If we get 2 out of here, we can have it over 1. But we can see here, you don't really have to write over 1. we have two answers to this problem, 6 plus or minus 3 root 6. Again, if you're having any trouble, make sure you're seeing your teacher about these because we are here to help you.